This is the video describing Telser's criteria for a safety first rule. So basically, what does Telser's criteria do? It sort of combines the rules of both Roy and Karaoke and creates a rule based on a combination of those factors. Okay, so basically, what are you doing? You're maximizing the expected return once you've established that Karaoke's criterion is met, and then you also check that the minimum lower bound return that you wanted has also been crossed. Okay, so if you wanted 5%, you're only going to keep the portfolios that give you an RL, a lower bound return of 5% or more. Okay, so after you've checked Karaoke's criterion. Okay, so basically in mathematical formulation, it would be maximize the RP bar, which is the expected return, right? Such that the probability that your portfolio return falls below that minimum specified return is less than alpha. Okay, so we're kind of locking that area in just like we did in Karaoke. Okay, so if we also realize from previously, if the returns are normally distributed, so we're assuming a distribution in order to make our calculations a little easier, then you'd say RL is less than or equal RP bar plus the Z associated with that alpha times sigma P. Okay, this is exactly as from the Karaoke video, so if you are wondering how that came up, you can check the Karaoke video. Okay, keep in mind that z is usually a negative number because we're on the left side of the normal distribution. So this plus z alpha, if we're talking of 5%, becomes minus 1.65 and so on. Okay. Similarly, the RP bar then is going to be RL minus z alpha times sigma p. Okay. So basically, I'm just bringing this term over to the other side, right? Over to this side, so it's RL minus. And if this left-hand side is less than the RP, then that means RP is greater than the RL side, okay? So that's what happens here. That's how the sign flips, okay? RP bar is greater than RL minus Z sigma P. Once again, this Z is a minus number, right? It could be a minus 1.65. So that'll become a plus 1.65 times sigma P, okay? So basically what is Telser doing? In addition to choosing between a portfolio, the criteria is also telling you to think about, should we make the investment at all? Um, if the minimum return that we want is not being met, then what's the point of investing in that in the first place, right? You might not want to invest at all. If you wanted 5% as your lower bound return, with a certain probability of that happening, and you see that none of your portfolios is giving you 5%, you may not want to invest in those three portfolios. Okay, you might not want to put your money into a portfolio of risky assets. Instead, you might consider investing in riskless assets. Okay, because that can guarantee a return that you're looking for. So Telser, that's the next step between Roy, Karaoke, and Telser. Okay, Telser has taken it up to the next level. Is hey, we're not just choosing portfolios even if we didn't want to invest. Okay, we're first going to decide, do we want to invest? And once we've made that decision, we can choose between the portfolios that we choose. Okay, so let's go to one of the examples. I'm going to start off with the textbook's example, which uses table 11.1, which has these three portfolios. Okay, portfolio A, portfolio B, and C. Portfolio A has an expected return of 7, standard deviation of 10. B is 8.5 and 15. C is 10 and 20. Okay, and then it says assume a probability of less than 5% of returns following below the lower limit RL. Okay, that means we're sort of locking ourselves to this tail, right? The 5% area in here. That's our alpha. Alpha is 5%. We know that the z associated with that alpha is minus 1.65. Okay, so we're going to basically do that. We're going to lock ourselves in there. Remember, this z now has to be translated to an RL so that we can compare. And it says check which portfolio you choose if your lower bound of returns that you do not want to fall below is minus 20%. Also check with minus 25%, and you're going to notice that you make different decisions based on those two factors. Okay, so let's go ahead and try to choose them. So basically, we start off by asking what is the RL. Okay, what is RL for the three portfolios? Okay. So we remember, if you don't remember, you can look at previous videos as well. RL, is equal to R bar plus Z times sigma P. Okay, this is the z associated with that alpha. You can write it as that way too. The z associated with that alpha is minus 1.65. Okay, so we're going to use that number. So let's look at portfolio A. What's our R bar for portfolio A? 7, right? So we have 7 minus 1.65 times the standard deviation of A, which is 10. Okay, 7 minus 1.65 times 10 will come out to minus 9.5%. Okay, for portfolio B, we do the same thing. We have 8.5 minus 1.65 times its standard deviation, which is 15. And that takes you out to minus 16.25. Minus 16.25%. Okay, and for portfolio C, we have 10 minus 1.65 times 20. And that turns out to be minus 23%. So now let's look at it when RL is minus 20. Okay, when RL is minus 20, if you notice, we have three lower bound of returns. Okay, A is minus 9.5, B is minus 16.25, and C is minus 23. Okay, there's only two portfolios in here that give you a lower bound of return that's more than your cutoff number. Okay, only A and B are higher than minus 20%. Okay, C is not higher, it's lower than minus 20, so that portfolio gets dropped. Okay, this is not in the competition anymore. There's only A and B. And now once we've chosen our two competitors between A and B that meet both our requirements, now we go into the expected returns area to look at which portfolio has the higher expected return. Okay, we only looking between A and B. B has the higher expected return, so we're going to choose B. Okay, choose B with R bar B is equal to 8.5%. Okay, remember, just so you can think about what I did later, our A bar was 7%. Okay, that's why we don't choose it. It's greater than our A bar. Okay, now think about it when you have RL being minus 25%. Okay, now you're saying, hey, I'm not caring about 20% anymore. My lower bound is now 25%. I do not want to fall below 25%. So now let's look at our three competitors. It's the same problem, okay? And you're going to see that we're going to make a different choice based on that, okay? Now, all three, A, B, and C, all of them are below minus 25. All of them are above minus 25%, okay? They're all meeting our requirements. Minus 25 falls to the left of these three numbers. So they're all three in the competition, okay? Now, once we've said what our competitors are, we go back into the table, take a look at their R bars. Okay, we look at what is the expected return for the three portfolios. So the highest expected return for the three portfolios is 10% for C. Okay, so once we've put our cutoff to be minus 25%, our lower bound of returns, we're actually going to pick C. Okay, so basically, in our order of operations, we'd say C was a better choice than B, and B is a better choice than A, okay, at this point, because they all sort of fulfill our requirements for Telser. Okay, I'll do another example with the numbers that I had set up in previous problems. We have these three numbers, a portfolio with an expected return of 8 and 3, 11 and 5, and 14 and 8, okay, and we're letting our alpha still be 0.05, okay, so we're still at 5%. Alpha 0.05 gives us that Z for that alpha is minus 1.65, okay? And then we say, hey, this time we're going to test for three different cutoffs, okay? We're going to test for 5% as our lower bound, 2% as a lower bound, and 0% as our lower bound, and see what we pick, okay? And you'll see that you might have different choices every step of the way, okay? We'll find out. So let's first find the lower bound for A, okay? RL is going to be RP bar plus Z alpha times sigma, okay? So we have 8 plus, but our Z is a negative number, so instead of plus it becomes minus 1.65 times 3. That turns out to be 3.05%. Portfolio B, we have RL is equal to 11 minus 1.65 times 5. That leads us to 2.75%. In portfolio C, the RL is now 14 minus 1.65 times its standard deviation, which is 8. Okay, and that turns out to be 0.8%. Okay, so these numbers are all expected values, right? The expected return 8 minus 1.65 times its standard deviation, 11 minus 1.65 times its standard deviation, 14 minus 1.65 times its standard deviation. Okay, and we get these three numbers. And now we're going to check based on our three cutoffs which portfolios do we choose. Okay, so if our portfolio required minimum return was 5%, okay, if we wanted to not fall below 5%, we can observe that none of these three portfolios meet 5%. Okay, if none of these three portfolios meet 5%, we don't choose any of them. Okay, we don't pick any of them. So we are indifferent. Okay, because it does not meet our requirements. Okay, because none of these portfolios are meeting our 5% cutoff. Now let's look at it from a 2% standard, 2% case. Okay, we're still looking at the three lower bound returns we calculated. Now we see that, hey, when our cutoff is 2%, if we do not want to fall below 2%, we actually have some players, okay? We have portfolio A, which is above 2%. We have portfolio B, which is above 2%. And now we're going to try and pick between these two, okay, between A and B. What's our rule to choose between those two? We go back to Telser's criteria, which says pick the portfolio with the highest expected return. Okay, so we come back here. We look at these two portfolios. Which one has the higher expected return? It's portfolio B with an 11% expected return. Okay, so we're gonna pick portfolio B. Okay, so basically in this case, B is better than A. Okay, but do not pick C. Okay, B is better than A. Do not pick C. All right. And now for the third one, if we're considering a 0% cutoff, okay, so you say we do not want to have negative returns. We want to restrict the probability of negative returns to be less than 5%. Okay, so our cutoff is now 0%. We again look at our three calculated lower bounds. We have 3.05, 2.75, 0.8. Okay, this time all three of them are valuable choices. Okay, are valid choices. A, B, and C are all above 0%. Okay, so now when we're trying to pick between A, B, and C, we're going to use the expected return to pick between them. So which one is the highest expected return? It's portfolio C with an expected return of 14. Okay, so this time we pick portfolio C. Okay, and basically C is better than B, which is better than A. Okay, this time our order of operations is we're going to pick C, then we're going to pick B, then we're going to pick A. Right? So basically, that is Telser's rule with two examples solved, and hopefully this makes it a little clearer for understanding what are the differences between Roy, Karaoke, and Telser.